Throughout the many videos in chapter 5, we have encountered various situations in which we have multiple forces acting on an object which is undergoing a straight line displacement from an initial position to a final position. We can determine the work done by each of the forces, and we found out these forces can be either positive, negative, or zero depending on the situation. Now, we are going to classify these forces that are acting on an object. We are going to classify them into two different kinds of forces. Depends on the characteristics of the work done by those forces. So we can have different types of forces acting on an object. It can be a weight, tension, external force, normal force, static friction, kinetic friction. And for these forces over here, we'll study their work done, the characteristics of their work done, in order to classify them into two different types of forces. One we call the conservative forces, the other one we call it the non-conservative forces. So what is the characteristics of work done that we are interested in to classify them into conservative or non-conservative force? We look at whether the work done is dependent on the path to go from the initial position to the final position or not. So let me put it here. If a force is conservative, we know that the work done is independent of the path, or you can say it's not dependent of the path. So if it's not dependent of the path, it depends only on the initial and final position only. So it cares about where you are earlier, where you are later. It doesn't care how you get from the earlier position to the later position. The path in between is none of our concern if we talk about conservative force. For non-conservative force, the work done is dependent of the path. So it depends not only on the initial and final position. So it means by you have an earlier position, you have a later position, but for non-conservative forces, the work done here is dependent of the path. So it means by we also need to know how you get from the initial position to the final position. What is the path in between? That is important to calculate work done for non-conservative force. Okay, so to give you a better idea what do we mean by dependent and independent, right? Imagine we have a situation where we are asked to find the work done by this force F over here. Okay, or let's say we try to classify whether this force F here is conservative or non-conservative. If you want to check whether this force F is conservative or non-conservative, what do? Is we take a situation in which we have an initial position and a final position. Then next, we try to determine the work done by this force F over here when it undergo displacement using a first path and another second path. So it means that we try to determine the work done by F here if the object undergo displacement using path 1, and we do it again, finding the work done again. By this time, the work done by force here is for the object undergoing path 2 to go from initial to final position. So we use two different paths to calculate the work done by F, and if the two paths give you the same work done, then that means your work done is independent of the path. No matter you switch between different paths, if you still get the same work done, that means the work done doesn't depend on the path. It depends on the initial position and final position only. Okay, so let's say work done by F is the same for path 1, path 2, and any other path in between the initial and final position. Let's say you create a path 3 that moves like this from the initial to the final. Then you calculate work done, it's the same. With path 1, it's the same as path 2. Let's say you try another path 4 in which you draw a big circle to the final position. And you find out that the work done is still the same as path 1, path 2, and path 3. That means no matter what path you choose to go from initial to final position, this F here will still give you the same work done. If that is the case, that means this force here is independent of the path. It is only dependent on the initial and final position only. If that is the case, then we will know that this force here is a conservative force. Okay, so what if today you have another kind of force and you try to determine the work done using path 1 and you try to determine the work done using path 2. If these two paths provide you different answer for your work done, that means the path actually decides how much work done will be produced by the force. That means the work done here is dependent on the path. You take path 1, you get a kind of work done. If you use path 2, it will give another answer for work done. Of course, if you take path 3, path 4, then you get different answer for work done. If that's the case, it's dependent of the path, not just the initial and final position only. So in that case, we can conclude that this force here is a non-conservative force if it gives you different work done for different path. So in the next video, we'll try to analyze in detail what kind of forces are conservative, what kind of forces are non-conservative forces.